On this question, we want to find f plus g, f minus g, f times g, and f divided by g. And we also want to determine the domain for each function. So I'm going to start by finding the domain of each individual function we're given. F of x is square root of x, and g of x is x minus 15. F of x is a square root function, and we know that square root of a negative will produce imaginary numbers. Square root of 0 and square root of a positive will give us real numbers. So we can find the domain of this by setting the expression underneath the radical greater than or equal to 0 and solving. In this example, the expression is x, and so there's nothing really to solve. The domain will be all numbers that are greater than or equal to 0. And so that is a domain. I'm going to say domain of f is going from 0 to infinity. The function g of x is equal to x minus 15, and that is a linear equation, which is in the larger category of polynomial functions. And all polynomial functions have a domain of all real numbers. So we know that the domain of g is all real numbers or negative infinity to infinity. So let's take the time to find f plus g. F plus g of x is the name of our function, but it also tells us how we can construct the function. We want to take a function called f and add it to a function called g. And f of x is square root of x, and g of x is x minus 15. None of these are like terms, and so we're going to leave this one just like that. Now, when we take two functions and combine it like this, we have to consider the new domain of this function. This portion is only allowed to be greater than or equal to 0, and this portion can be anything. So because this one piece is restricted, the whole function is restricted. So the domain of f plus g will be from 0 to infinity because one piece of it is restricted. Then let's find f minus g. So once again, f minus g is the name of the function, but it is also telling us how to construct it. We want to take the function f of x and subtract g of x. That's square root x minus the whole function x minus 15, so we need to make sure to distribute that minus. So that's square root x minus x plus 15. And we want to find the domain of this function. And once again, this piece is restricted, this piece is not. But because one piece of it's restricted, we need to use that restriction for the new function. The domain of f minus g is from 0 to infinity because of that restricted square root. So let's find f times g. F times g is the name and also how to construct it. We're going to do f of x times g of x. That's square root of x times x minus 15. We could write this, we could do the distributive property to simplify, and that would be x square root x minus 15 square root x. This radical is restricted. The x and the 15 are not, but since one piece is restricted, the function is restricted. So the domain of f times g will be from 0 to infinity. So we've got one more to go. That's f over g of x. We're going to construct that by doing f of x divided by g of x. And f of x is square root x, and g of x is x minus 15. There's not really much we can do to simplify this expression, so we're going to leave it. But we do want to consider the domain. This piece in the numerator is restricted because of the radical. It has to be greater than or equal to 0. And this piece in the bottom, because it's in the denominator, is also restricted. It cannot equal 0. So in the denominator, I need to figure out what value is restricted. X minus 15 equals 0. We're going to add 15 to both sides and get x equals 15 as our restricted value. So I'm going to take this one a little bit slower because we have an extra restriction. So let's think about that on the number line. Because of the radical in the numerator, we know that x is allowed to be values greater than or equal to 0. It is not allowed to be these negative values because square root of a negative would give you imaginary numbers. And then we have this second restricted value of 15, and that is over here somewhere. So we need to exclude that value of 15. And because we had to exclude 15, that gives us two separate shaded regions, and we're going to write down those intervals for our domain. So this interval here begins at 0 and goes to 15, and 0 can be included, so we're going to put a bracket, but 15 cannot. So we'll put a parenthesis. And this interval here begins at 15 and goes to infinity. And so we have the domain of f over g can be from 0 to 15, including 0, and 15 to infinity, not including 15. Thank you for checking out my videos. Have a great day.